All right, guys. So far we have completed two chapters in part one. First one was numbers, then we completed squares and square roots, and this is the third chapter in the series, and we will finish here cubes and cube roots. But before that, let me just go back and clarify two things that we covered in squares and square roots. So, while discussing the properties and patterns, we were a little stuck with respect to these triangular numbers. Now, I just want to show you. Okay, I said 1, 3, 6, 10 are triangular numbers, but what does a triangular number look like? So, I have a snippet from the textbook. You can get from NCERT textbook. So, this is how the triangular numbers look like. Triangular numbers for 1, it is represented like this. For 2, it is 1 2 and it is adding up to 3, and for 6 it is 1 2 3 and adding up to 6. For 10 it is 1 2 3 4 and ending up to 10. Similarly for 15, 1 2 3 4 5 and it's adding up to 15. So that's why these numbers are called triangular numbers. They can be represented in a triangular form, and when adding up to those things, this becomes the sum. Okay. So that's about the triangular numbers. Then another thing we were discussing, and you are not clear of the pattern. So this is the interesting pattern that we discussed in the last chapter regarding how these numbers look like when somebody is making 1 square or 11 square or 111 square or 4 1 squares or 5 1 squares, so on and so forth. So this is how the patterns look like, and that's why it is saying, okay, there is an interesting pattern when making squares of these 1 1 1 kind of numbers. So it's saying 1, then 11 square is 121, then 1 1 1 square is 1 2 3 2 1. You see the nice pattern here saying 3 in the middle and 2 1 2 1, and so again 4 in the middle and 3 2 1 3 2 1. So that's why it was just showing, okay, when we do squares, how interesting patterns are coming. Maybe for few calculations you may get some objective, it would be easier for you to write it down quickly, but it's better to know it. Now let's just quickly jump into the cubes and cube roots, and so that's the chapter we are discussing today. Let me go to slide. So okay, play. Okay, this is the mistake I've been doing. um, Cubes and cube roots, and play from current slide. Wow. Okay, cubes and cube roots. What is that? What is a cube? When a number multiplied by itself for 3 times the resulting number formed is called a cube number. Simple, as much as the square is. Square means multiplying by itself twice, here multiplying by itself thrice. Examples. Suppose say n cube equal to n, where n is called a cube number. Examples are given here. 2 cube equal to 8, 3 cube equal to 27, this is wrong, and 4 cube equal to 64. Okay. Next one. Just as much as square root, cube root is also is reverse of cube. As in above case, m is called cube. Yeah, in this example this is also some typo, where it should be n is yeah, m is called cube root of n. Yeah, that's correct. M is called cube root of n, and it is denoted by this symbol. You see this square root kind of symbol with 3 in the prefix. It is representing it as a cube root. That's as simple as that. So per se, n is cube of number, then cube root of n is m. That's what it is. Sorry. Examples: cube root of 27, 3, cube root of 64, 4. So it's just basic understanding. You just know what is cube and cube root, and you will do some practice exercises. Next, patterns and tips before we do the exercises and examples. What are the patterns? First in this series is numbers that can be expressed as sums of two cubes in two different ways are called Hardy-Ramanujan numbers. So this is something in the mathematical world. There is some discovery. There are some interesting numbers which can be expressed in two ways in sums of two cubes, right? So and that is kind of um, making it a very interesting number and very special number. So that's what these two gentlemen figured out that, and they named it as Hardy and Ramanujan numbers. Now let's just see what are those examples. So per se here one example is 1729. 1729 can be represented as um, 12 cube plus 1 cube, that's 1, 10 cube plus 9 cube. So this is the pair where this Hardy and Ramanujan number can be represented. Okay, next pair 4104, where the sum of the cubes of 2 and 16 is one pair, and sum of the cubes of 9 and 15 is another pair. Similarly, another example of 13832, where it is saying sum of the cubes of 13 and 20 is one pair, and sum of the cubes of 2 and 24 is another pair. This is the first tip in the cube and cube root series. This is an interesting number series. I mean, these are the interesting numbers. Next one, adding consecutive odd numbers can result to a cube. This is again another pattern. They are saying that adding consecutive odd numbers can result to a cube, and we will just see a few examples in there. So just by just saying 1 equal to 1 cube. Another example is this odd number 3 plus 5 equal to 2 cube, and these odd numbers 7, 9, 11 can be 3 cube. So just interesting patterns you have to remember just for the fun sake. Next. Each prime factor appears in a cube three times. So this is also something, some discovery that um, in a cube a prime factor appears three times. Let's see what is it. Okay. Okay, this is coming back to the previous one. Each prime factor appears in a cube three times. Yeah, so cube has right, so this is obvious, right? I mean, I don't know what kind of pattern is it. So prime factor, if we represent a 12 cube, yeah, and if you see how the prime factors are laid out there, so you need to make a pair of three, not like pair of two, unlike squares and all. So next one is again we will start with the examples and tricks solving this. So it's saying that 6859 cube root equal to 2p minus 1, then what is the value of p? Now you need to figure out what is the value of this one, 6859 to the power 1/3. Let's see, what's the value? Yeah, so if we figure out this number, the whole catch is if you figure out this number, solving this simple equation would be piece of cake. So this is what it is showing. 6859, and we are using the prime factorization. It is showing that 19 should be the value. Okay, and then 19, it's simple then to solve. 19 equal to 2p minus 1, that equal to p equal to 10. Okay, so this is a simple example. Next, prove that the number is doubles, then its cube is 8 times the cube of the number. Yeah, I mean, this is basic maths in that. Per se, you have 3, okay? 3 cube is 27, and then you have 6, which is double of 3, which should be 6 cube is 8 times of 3 cube. That's what it's saying. It says a number. Um, Double of a is 2a, okay? And then it is saying that, okay, a cube is there, but 2a cube equal to 8a cube. 2a's whole cube equal to 8a cube. Okay, so that's there. Okay, this is very simple. The patterns and tips are limited in case of cube, and but you need to practice a lot all the exercises in the textbook to not forget anything. So practice is the only thing. It's giving here. This is the chapter 7 in the textbook where you can go. It should be exercise A, B, C would be there. Just practice them all the questions to know all the kind of tricks so that you can remember for longer. So that's about cubes. Next topic here is comparing quantities. Okay, so this is very short chapter on cubes, and we will cover more and more now. So we will combine this cube and comparing quantities together, and then we will combine the chapters of powers with proportions together. How about it? I think that will make it simple. So now that we understood numbers, squares, square roots, cube roots, now let's see how we can use this number and square and cube knowledge to one step further by doing some problem solving. Okay, comparing quantities is nothing but problem solving, and let's see. So comparing quantities is just about understanding situation, few terms, and solve few problems, right? So you will be exposed to bunch of terms while we go through this chapter, and we will see how we are using those terms and definitions to solve the problems. This is not that tough as figuring out square root or cube root kind. This is very simple. As long as you understand numbers, terms, and definitions, it would be a piece of cake. Next. So comparing quantities, first concept we need to know something about ratios. So what are ratios? Ratios means, you know, right? Kind of, we can represent it as fractions, or ratios means parts, right? So we'll see examples. Ratios have a lot of significance while comparing quantities. That's why we need to know what are ratios. Example, you can say 2 out of 5 parts, or you can say 2 is to 5, or 2 by 5, right? Or you can say that 40%. So either you can say represent it in various ways. You can say 2 uh, parts out of 5 parts. You can say 2 by 5 or 2 is to 5, or you can say in percentage also. It's saying, okay, 2 by 5 multiplied by 100 it is going to give you 40%. So whether it is percentage or ratios, not much difference. That's what it is trying to explain. Now, another term. So, while comparing quantities, these things you need to know ratios, discounts, tax, and all those things. Because this comes under a little bit of problem solving. Discount. What is discount? This is basically what is the reduced on market price. Okay, discount means everybody knows when they go to a store and ask for a discount. What is reduced on the market price? That's the discount. Discount equal to MRP, max retail price minus sale price. So if sale price is the amount you paid to purchase it, and what is the MRP, you subtract those, then you will get, okay, what discount you got. There are some overhead expenses involved while buying or selling the product, and that increases the price of the product. This is also another concept it is making you aware of, not necessarily about discount, but it's saying, okay, uh, uh, current price equal to, I mean, buying price plus overheads. So per se, you decide what price you're going to sell, and then you put some overhead charges, logistic charges, to procuring and selling that, market that. There are some charges. So it's saying that okay, it's not just what you decide for the buying price, but you need to put the overhead cost before selling it. So this is just helpful to solve few problems. We will come into it in a while. Um, Another concept it is trying to expose you is called taxes. Taxes consider while purchase. So one in this category of tax is called sales tax. What is that? Tax paid on the sale price. Per se, you are buying something, then you need to pay the sales tax. So without paying that, then um, actually if you're not charging the sales tax as a store owner or somebody, then it would be out of on your pocket. So government has to take few taxes to keep the administration in place. So it is using various mediums to collect the taxes. Whether you have income, it is put the tax. Whether you have a retail shop, then while doing the exchange or purchase, it put tax. Sale tax is one in that category, tax paid on the sale price. And there are some taxes as value added tax. So there are some goods which go under value added goods, and in addition to putting sale tax, they also put value added tax, because sale tax are on minimum basic amenities kind of stuff, but for value added means luxury utilities, VAT will be there. So these are the terms when you do problem solving. These terms will appear, so you should know what are the things you should consider to solve the problem, and that's the reason it is exposing it to these things. So next one, additional tax added. What is additional tax added? Uh, so that will be a simple expression. Um, we got to know what is sale tax, we got to know value added tax, but in recent times, per se last 6 7 years, we are exposed to this term called GST, goods and service tax. So GST is kind of super thing, right? um, so sale tax would be there, VAT would be there. Those are kind of old stuff, old way of tax model. Now GST is covering everything and just saying, okay, this is the price plus GST. What's the cost of this television? So television cost is 50,000 plus GST. That means they're clubbing all the taxes together is a category called goods and services tax, and just putting on it. This is also another tax added. It's showing it 6 years back, 2017, both on goods and services. Okay, interest. You should know what are the interest also. So this comes when you, I mean, buying, lending or borrowing money. You need to know the charges added while borrowing money from banks or institutions, also money received while money deposited in these institutions. So while borrowing money or putting money into the savings or fixed deposits, whatever pricing is done is called interest. But so you're borrowing money, you need to pay interest. You're saving money, you will get interest. Okay. Interest can be either simple or compound interest, but banks always consider compound interest, because simple interest means you're losing money. So compounded, the interest is compounded year after year, in the sense that per se this year it is 100 rupees and you're getting 10% interest. So next year it would be 110, and then the following year the interest will be on 110, not on 100 again. Then you would be losing money, right? So that's what it's trying to explain. So this is what so this is the principal, this is the rate of return, and it is showing amount compounded equal to a simple equation P 1 plus R by 100 to the power n, and is the time period of the tenure of the interest period, how many tenures are there, and this is the principal, R is the rate of interest. So it is simple, it is compounded. This is the simple formula to compound the interest and give you the what's the amount compounded, right? Okay, now we will go ahead and solve some questions on this, so that we will know how we are going to add the learnings we received now. Okay, So this is one question where it is saying Sham purchases a scooter at 36,450. There is a 9% sale tax. Then the total price paid is, so it's saying that try to include the sales tax before calculating the total price. It's saying, so it's not asking in the question consider other terms or the taxes and all. It's just saying okay, if the purchase is of this thing and there is a 9% sales tax also involved, then what would be the purchase amount? So it's saying okay, um, you have a pricing told to you for the scooter, and then you will put the sales tax on it, and that comes the overall price. For example, I am going and buying a car. I'm buying a car. If you see the cost breakup, you will see okay, this is the showroom price plus so there is something called ex showroom price and there's a total price. So ex showroom price plus these taxes. So in that case, it is road tax. Here it is just explaining it as sales tax. So 9% is the sales tax. So we are multiplying it like this, and we are getting 39. Okay. An article marked a price of 1200, and the discount is 12%. Then what you should say? Okay, MRP, you are getting the discount, and then you are saying that okay, 12% discount. That means 88% of the MRP, and the pricing I can purchase on a sale or a discounted price is that 1056. Mark price of the article is 500. Shopkeeper gives a discount of 5%, still makes a profit of 25%. What is the cost price? So this is telling you is very traditional concept. Okay, these discount sales are there, but what exactly is the cost price? So they are showing the discount, but still they running the show, so they have to make some profit, right? So it is saying that okay, discount is already given 5%, so that means the sale price is 95% of the mark price, but shopkeeper already keeps a margin or a profit of 25%. So what is the cost price then? So then it is saying okay, this is the sale price by 25% margin has been taken, so which is 1.25. It divides it by 1.25 so that it know what is the value of one, or what is the, so the sale price is almost 125% percentage of the cost price, and from this problem that's what it is explaining. So it just divides it by 1.25 in the forms of ratio. So then it knows that okay, so this is the sale price, and but the actual cost price is turning out to be 380. That's the answer. Monthly telephone charges has base amount of first half month with service tax 12%. The base amount of the last half month with service tax of 10%. The whole month will also includes education. So it's saying that calculate the monthly bill. Where the first half month the base charges are this, but it will also include a service tax of 12%. The next half month will have a base charge of this, but it will also include a service tax of 10%. You see here when it was around 200, the service tax is 12%. When it is around 600, the service tax is around 10%. It has increased, a decreased a little bit. So that's how the pricing, tax pricing they have kept it. And the month will also include education cess. So in addition to these taxes, some bills will also contain education cess, social security cess, and so and so. So this, in this problem we need to consider also education cess. So what it is saying that include the service tax on around this 199.75 plus include the service tax on this 599.25. So this is the amount that comes out to a bill, but you need to include the education cess of 3%, and the overall amount of the monthly telephone bill turns out to be 909. So that's how it's saying how the monthly bill is calculated. If you expose yourself to these things, then you will be aware of many concepts. Okay, how purchase pricing cost breakup works, how these monthly electricity and telephone bills are calculated. All these things they wanted to kind of make the students aware of. So these concepts are in place. Okay, now this ends this chapter. We will continue in next chapter 4 about exponents and power. Thank you guys.